Welcome back, everyone, to another episode of Engineering Quality, the podcast where we dive into the art and science of building quality software. I'm Veronica, and as always, I'm here with my amazing co-host, Royally and Ellie. Hi, ladies.
Hi, Veronica. Hi, everyone. Great to have you with us today. And if you're new here, welcome. And to our existing listeners, welcome back. On this podcast, this is where we unpack everything from foundational testing strategies to the latest industry trends. And so, no matter your level, we've got some insights for you.
Hi, everyone. This is Ali. And yes, that's right. We do love to talk about software engineering and testing. And today we are focusing mainly on a topic that we believe will be interesting for everyone in software engineering. We'll be talking about core testing strategies for engineers. And we're going to include a few buzzwords in there, like shifting tests left and the test automation pyramid. So I would love to unpack that today. So whether you're a seasoned engineer or just stepping into the world of testing, today's episode is packed with valuable takeaways.
Totally. We will start by exploring what it really means to shift left on testing, why it's so much more than just a buzzword, and how it can transform quality outcomes. Then we will move on to the automation pyramid, breaking down the layers and discussing how to build a balanced testing strategy that fits your team.
And we're not just talking theory here. We'll be sharing real-world examples, some common challenges teams face when adopting these approaches, and practical tips on making these strategies work, no matter the size of your team or product.
Yes, and so get ready. We are going to unpack a lot today. So by the end of this episode, we hope that you have the tools to boost your own testing practices and ultimately deliver higher quality software.
All right, let's jump in. Let's dive into the heart of today's episode first. What every software engineer really needs to know about testing. Sometimes it feels like there is a divide between engineers and testers, but at the end of the day, testing isn't just a tester's responsibility. It's a team effort, right?
Absolutely, Veronica. And although testing is often someone's role within the team, it is also an activity for everyone to perform. Testing is about finding information about the system, and the earlier we start getting that feedback, the better it will be overall. So in great teams, quality isn't something that gets inspected at the end of development. It can be woven into every line of code from the beginning. And engineers play a huge role here since they are closest to the code. So they'll start by writing tests and thinking about the quality of the software as they build.
Absolutely. And that's where concepts like shifting testing left come into play. When we say shift left, we're talking about bringing testing earlier into development process, ideally at the design and coding stages. If engineers test their own code early, we catch issues before they become big problems, and that can save a lot of time and effort down the line.
Totally agree. And with shifting left, it's not just about running tests earlier. It's about adopting a preventative approach instead of a detective one. Think about test-driven development, or TDD in short. It's one of those practices that encourages engineers to write tests before the actual code. This approach keeps code tight, clean, and aligned with expected outcomes right from the beginning.
Yes. And, when we talk about test-driven development, I also like to talk about the different levels of testing. We're not going to go into a lot of detail here because that's not the core of this podcast, but just to touch on the different levels of testing. You have unit tests, integration tests, end-to-end tests, all of which can be automated. We have also tests that are performed without the help of a tool. So some people call it manual testing, exploratory testing, when we are using our brains as a tool instead of something that can be repeated over and over. So, when we talk about levels of testing, we also talk a lot about test automation coverage, not just what testers do at the end-to-end level, but also code coverage at the unit level and the integration level as well. And it's important to mention that not everything should be automated. There is this idea that I hear sometimes from engineers and engineering leaders that, we should just go out there and just try to cover as much as possible or everything we can possibly cover. And yes, automation is powerful, but it's also costly. There's a maintenance cost to it as well. So we need to be really thoughtful about what we are going to cover with that. So, and there's also the other types of testing that we need to invest on, such as exploratory testing as well. So we can't spend all of our time in one type of testing alone as well. Because if you think about it, automation is great for the things that you can anticipate. So covering acceptance criteria, that sort of thing. But there is things that we can't anticipate. So we'd have to do some exploratory testing around those to cover edge cases. So what I like to say as a starter and as a good rule of thumb, that if a test has to be repeated over and over from one sprint to another, that's a good candidate for being automated, amongst other things. But that's for me the very first thing I look at when looking about automating is, do I want to make sure this function or this part of the function works every time? And if the answer is yes, then it's a good candidate for automation.
Yeah, well said, Ali. And, you really can't stress that enough, right? Because everything should not be automated. And it's so important to only automate the things that are good candidates. And you mentioned edge cases. And, speaking of edge cases, engineers should always consider testing these what ifs, right? So testing isn't just about testing the happy path. And the happy path is when you give specific inputs and the expected output and it works as expected, right? So that is the happy path. There are also sad paths and, these negative scenarios that it's so important to test because you have to be prepared for the unexpected. And as engineers, they can help by thinking critically about what could go wrong, like unusual inputs or extreme conditions, and building tests to support these.
Yes, absolutely. And again, when we talk about those tests, we're talking about unit tests as well. So there is no reason why we can't have edge cases at the unit test level as well. We shouldn't just be covering the happy path at that level too. So I totally agree, really. And there is other types of tests as well. Let's not forget non-functional tests like performance, security, and accessibility testing as well. Sometimes they don't get as much focus or the focus that they really deserve, but they're really essential to ensuring a robust system. Engineers should understand that quality goes beyond just the features that they are delivering as well. So it's great to have those conversations and have processes around the non-functionals as well. It's all about how the software performs in the different conditions and whether if it's secure or not.
Such great points, ladies. So to sum it up, testing for engineers is about integrating quality throughout the development process, balancing automated and manual tests, and always keeping an eye out for unexpected. It's a mindset shift towards thinking of quality as something that's built in from day one.
Well said. And if engineers keep that mindset, they're not only improving their own code, but they're also contributing to a stronger, more reliable product for everyone.
Yes. So, all right, we've covered some key ideas here. Next up, we're going to dive a little bit deeper into shifting tests left and how engineers can get started with this approach in the daily workflows. So we hear the term, the buzzword, shifting test left a lot these days, right? Let's just take a pause here and really talk and break down exactly what it means to us and how we can make that work effectively amongst engineering teams.
Yes, let's do that. I think it would be a great start. So, shift left testing basically means moving testing activities earlier in the development life cycle. Instead of waiting until the code is complete, we're integrating testing into every phase, from planning and design to implementation. This allows us to catch issues as early as possible, which ultimately leads to faster, higher quality releases.
And what's great about shifting left is that it's not just about finding bugs early. It's about designing software with quality in mind right from the start. By making testing a proactive part of each stage, we're less likely to face surprises at the end of a sprint or a release cycle. So, how do we actually go about shifting left? What are the steps teams can take to make it a reality?
Good questions. There are many different ways we can do it, right? So one effective way to shift tests left is what we talked about a little bit before, test-driven development, or TDD. So with TDD, you usually write your test cases before the actual code is written. So thinking about that quality mindset, you think about what tests do you want to see passing before you have the code being written. It forces you to define clear requirements. And when I say you, I mean the whole squad. And we want to make sure that those requirements are really well defined for each feature, that it creates kind of a blueprint for the development process. So as a result, code becomes more modular and maintainable since it's built with testing in mind from the beginning. And one thing that I really love to talk about when I talk about TDD is to make it really clear that TDD is not a testing approach. Even though it has test in the name, a TDD is not a testing strategy or a test approach. It's really an engineering practice. So you can't get to a team, to a squad and say, hey, testers, go ahead and implement TDD here. That's not how it works. It's a whole team thing. So we need to make sure that this is implemented from the very beginning.
Yeah, especially if we talk about TDD, it's obvious that it would be better if engineers who are closer to the code would write those tests, because they're like, yeah, they wrote the code, so it makes sense. Okay, first, let me test what I'm going to write, and then write the code and see if my test passes. And if my test doesn't pass, then I didn't do my job yet.
Yeah,
Exactly.
It's a huge mindset shift as well. I think we talk about TDD like it's an easy thing to do, but I think, we need to give credit where credit's due. Teams that are working fully on TDD have had to go through a major mindset shift as well. So it is not an easy thing to implement.
And it's one of those things where once it's implemented, it's such a game changer that, as engineers, you can never go back, right? It really changes the way that you write code and the quality of code that you write. And it saves you work in the long run because there are less bugs. So it's one of those things, once implemented, it's a complete game changer.
So it's so true.
Totally agree. And beyond TDD, another helpful approach is pairing testers and developers during feature design and coding. By collaborating early, testers can provide insights on potential edge cases or areas that might need additional coverage. This cross-functional work straightens the design. And when we talk about design, by the way, here, we do not only talk about, how our UI is going to look. We talk about our code design, about our architecture. Those are the things that really impact testing very deeply, not what color of the bottom is going to be.
Yes, true.
Yes, so I'm coming back to this, right? Like cross-functional work straightens the design, our code design, and identifies potential issues before code is written.
Exactly. And let's not overlook the importance of defining clear acceptance criteria early in the process. Acceptance criteria, or the AC, right? It provides a concrete reference for testing and development teams, ensuring that everyone knows what done looks like. So for effective shift left, teams should work together to craft detailed acceptance criteria and review them before coding begins. And so one of the things that I love that's implemented in a lot of teams that I've worked with is once we have the requirements, right? It's so important for all the key stakeholders in the team to get together and to go through the requirements together, to understand what testing will look like, to understand what done will look like for the requirements, to understand ahead of time, like risks and all those things that we've discussed in pre-mortems and things like that. But it's so important to just go through as a team and really understand the requirements and understand if it makes sense and understand how you'll be able to test and all the things, the test dates and all the things that are needed ahead of time. Those are things that will save time in the long run, will reduce the amount of bugs. And these are things that help with the importance of this whole shift left idea.
Absolutely. I think that those are such great points because it's bringing collaboration into it. There is no point just having the acceptance criteria written down and not collaborate over them. So I really love that you brought that point up too, really. And a question here, like I've worked in many different teams and, when we do have those conversations over the acceptance criteria and the requirements. In your teams, ladies, who has in the past run those meetings? Like who takes note on actually running those meetings and making sure that everyone understands what the requirements really are? Is it always, a product owner, a product manager, or have you seen other people do it as well?
I think it depends. So sometimes it might be an engineer who is responsible for tech design. Sometimes it can be a tester. Sometimes it's product, right? Who is just like trying to align with the rest of the team. So I feel like it's interchangeable and anyone can take facilitator role in those. But as long as we are all aligned cross-functionally, this is what we need to leave this meeting with.
Yep.
In my experience, it's normally the product owner who really pulls the team together because they own the requirements in that they're the ones who initially write the requirements, right? But there's never a situation where you have a successful meeting if the key stakeholders are not there. So it's not normally a situation where the requirements are owned by the product owner just because they pulled the meeting together. It's normally very important that all the key stakeholders are present. As you said, Ali, collaboration, right? Because, and Veronica, you mentioned it too, we have to all be aligned with the requirements before any of the work even begins. So in my experience, yes, the PM will pull the meeting together, but someone representing the testing team has to be there. Someone representing engineering has to be there. Someone representing design needs to be there. Even legal, sometimes depending on the product, a lot of times you need to have like a copywriter present. It's very important to have, depending on the feature, depending on the product, to have all the key stakeholders identified and have them present and have them all aligned.
Well said. Yes, representation in those meetings and collaboration, I think, are very good points. So those are awesome tips. And just taking a little bit of a tangent here, though, because we're talking about shifting test left. And there is other things in modern testing strategies apart from shifting test left, right? Another great resource really is for us to start thinking about shifting test right. So if we think about shifting test left as testing as early as possible, shifting test right is testing it after it goes to production. How do we monitor it? How do we observe it? How do we make sure that things are working in production the same way that they were working in previous environments as well? There are lots of great resources out there about shifting tests left and right. I really love a couple of blog posts, and we'll post this on our notes so you can refer it to. But Lisa Crispin and Janet Gregory, they like to call shifting tests left and right holistic testing. And they have, great blog posts about this as well. Dan Ashby calls it continuous testing loop. So if you think about an infinite loop and you have developing on one side and pushing to production on the other, you have testing all along. You have testing from the very beginning to the very end, but there's no end really, because after it goes to production, there is maintenance as well. So you continue testing as well. So those are great resources for you to look into, but we'll post that on our podcast notes later for your reference. So all that really means is that testing is really a series of learning loops throughout the development life cycle. It's not just a phase within the development life cycle. So the earlier we can provide that feedback that comes from testing, the better.
Good point, Ellie. And another strategy to shift test left is code reviews. Code reviews are a fantastic way to catch issues early, and they become even more valuable when you approach them with a testing mindset. Instead of only looking for code styles or logic errors, review for potential test gaps, missing edge cases, and adherence to standards. I have seen great results with pairing testers and developers on code reviews. This brings a testing mindset to the code review process.
Exactly. I also find that shifting left is most effective when feedback is immediate, actionable, and specific. And I'd add that while speed is important, don't ever sacrifice accuracy or test depth for speed. Shifting left is about efficiency and quality. So make sure your early tests cover what matters most and give clear direction.
And remember, too, that shifting left isn't an all or nothing approach. The teams can and should really start small, implementing one or two practices at a time, get good at it, and then gradually expand to other ones as well. So with each step, you're improving the quality and catching issues earlier. So it doesn't matter if you don't do it as a big bang type of approach. So think about that.
So now that we've gone through the fundamentals of shifting test left, let's take a look at a model that goes hand in hand with this approach. And this is the automation test pyramid. And it's a great tool to know.
Totally, really. And first things first, I want to clarify that automation test pyramid is a model, not a strategy. It doesn't dictate specific actions, but rather provides a visual guide on how to structure automated tests to achieve balance, speed, and reliability. So, Ellie, do you want to walk us through what the pyramid is all about?
Yes, of course. So I love that you touched on the pyramid being a model and not a strategy, Veronica, because it does get confused with a test strategy sometimes. So it was really good to get that highlighted at the beginning. So going back to what the pyramid is, so picture a pyramid with three main levels. At the very bottom, at the base, you have unit tests. So it's the larger parts of the pyramid, it's the bottom part, which focus on your small pieces of code, like individual functions and methods. So these are fast, they run in isolation, and they provide immediate feedback on whether a specific part of the code is working or not. And since they are foundational, they should make up a majority of our automated tests. So the most test cases we can have in the unit test level, the better. They are faster to run, they are faster feedback, and the maintenance is much easier than the other levels that we're going to talk about.
And then moving up the pyramid, we have integration tests. So these tests check if different modules or services work together as expected. Integration tests are a bit slower and more complex than unit tests because they involve testing multiple parts of the application together, but they're crucial for ensuring that components communicate correctly. So some examples would be API testing or contract testing.
That's correct. And at the top of the pyramid, we have end-to-end test, which validates the application's workflow from the user's perspective. These are generally slower and more brittle because they test the entire stack, interacting with UI, services level, and databases. That's why we try to keep the number of end-to-end tests relatively low, using them only for critical user flows. Some of the tools we use for end-to-end testing are Selenium, Playwright, mostly like for web applications, and Appium, Espresso for mobile.
Right. So to give an example of this, right, let's say, for example, you have an e-commerce application. One of the features of e-commerce is adding an item to the cart. So you would add an item to the cart and you want to make sure that you have sufficient unit tests to test that feature to make sure that it is working as expected. But then there's another component, which is payment, right? So you add to cart, you want to be able to check out. So to test that the adding to cart works with payment would require integration tests. And then as an end-to-end user, right, you're not just going to go to the application and check out and go to payment. You want to be able to test that an end-to-end user can go to the website, can add an item to cart, can check out, can complete payment, all that stuff. So then that is where the end-to-end test would come into play. And the reason why these are at the top of the pyramid and are the smallest tests that we would have is because, as you can imagine, there are so many different features or components that you have to go through to really complete that end-to-end flow. And if one thing is broken, the whole test fails. And so it's important that each component as itself, you have a lot of tests that run quicker to make sure that these are working as expected, which reduces the time, as was explained, and allows for faster feedback. So if, for example, the product page is broken and you have unit tests to test like the product page component, you would get that feedback quicker and you could have that fixed so that once a user goes through the end-to-end flow, they're less likely to have as many issues.
That's true. And I want to highlight this is the reason why it's a pyramid, because and unit tests are at the very bottom, which is considered foundation. If we do not have solid foundation, then our pyramid will not be stable, right? And for example, if we have too many end-to-end tests at the top, and let's say not too many integration tests, and maybe some unit tests, then it's going to be kind of shaky.
Exactly, Veronica.
That's a great example. I think that really makes it super clear how the The automation pyramid model really relates to shifting test left, right? Because as we move down the pyramid, that has a correlation of shifting left when we're looking at the development life cycle as well. So let's always remember to try to have the bulk of testing at the foundational level, at the unit test level, rather than relying solely on end-to-end tests at the top.
Yes, and a huge advantage of this approach is that the earlier, faster tests catch issues as code is written, providing quick feedback, which we've mentioned a ton of times, right? So if we over rely on top of the pyramid tests, we're not only slowing down the feedback loop, but we're risking a test suite that's hard to maintain and prone to breaking with every minor change. And then obviously, no one would have confidence, no one would trust those tests. And we all know that would lead to a bigger issue.
That's so true, Riley. And that brings us to some of the pitfalls of the automation pyramid. And common mistake or anti-pattern that we see often is called ice cream cone model. Imagine the pyramid flipped upside down. It's heavy on end-to-end test at the top and light on unit test at the base. This can create a brittle test suite that's slow to execute and difficult to keep stable. This is exactly what we were just talking about, right? It's like it will be shaking one side or another, and it's like it will never be stable.
Exactly. And it's also very costly to run an ice cream cone type of automation strategy. Like if you have too much end to end, it's really costly. So the ice cream cone often happens when teams over focus on UI testing in order to compensate for other things, like if they don't trust in the unit or integration tests, or if they don't have unit or integration tests, or if they don't have access to it. I've worked in teams where we might not know or have access to the code in production, so we don't know what's being covered. And apart from having a conversation with an engineer, you don't really know what's in there. So there is a lack of trust there. So when that happens, one of the side effects can be that we over rely on the end-to-end because it's what we can see and control as well. So we think in those scenarios that we are covering more, but in reality, these tests can be really much harder to maintain, and they offer lower reliability too, and they are longer feedback loops on top of them.
And harder to maintain means more time on maintenance, which means less time for doing other tasks that we have as testers.
Exactly. And a variation of the ice cream cone anti-pattern was coined by ThoughtWorks, and they called it the cupcake model. And basically, it's when there's little to no strategy for testing layers. So teams might write a few unit tests here, a handful of end-to-end tests there, but there's no structure and little to no collaboration. And we see this a lot. And this leads to gaps in coverage and makes it hard to get consistent results from the test suite.
Right. And let's talk about how to avoid those pitfalls now. First, aim to keep a high level of coverage at the unit test level. If you have a strong foundation of unit tests, you can rely on them for immediate feedback without the overhead of full application testing. That's what really brings value to shift left approach.
Yes, and for integration tests, it's essential to think critically about the key interactions that you need to cover rather than testing every single possible scenario. Well-planned integration tests validates that different parts of the system communicate correctly without overloading your test suite.
Yeah, and with end-to-end tests, think lean and critical. These tests are for the most crucial user journeys, like logging in, creating an order, or completing a payment. If you keep the number of end-to-end tests small and focused, you get the coverage you need without bogging down the pipeline.
Great advice, Riley. So to sum it up, the automation pyramid works well with shift left testing because it focuses on early foundational tests that give immediate feedback. And if you are careful to avoid the ice cream cone or cupcake patterns, you will keep your test balanced, fast, and effective.
And again, once more, for those at the back, the pyramid is a guideline to help you prioritize. It's not a strict rule. It's a model for you to visualize and to have conversations about testing and testing coverage. and to keep your layers in proportion. So try to stay clear of those empty patterns, and your team will be set up for a sustainable and high quality testing strategy.
That was some great foundational knowledge on shift left testing and the automation pyramid. And I hope you'll find these insights helpful for building a robust testing strategy. Now, before we wrap up, let's dive into a question from one of our listeners in today's mailbag segment. So we've got a great question from a listener. It reads, I've heard about shift left testing, but our team has limited resources. What's the first step we should take to start shifting left without adding too much overhead? Who wants to go first?
I can go first. So I think that's a solid question. And honestly, it's probably the most common concern that I heard about shifting left. Shift left testing doesn't have to be overwhelming or require a big investment to start seeing benefits. One great first step I would recommend is incorporating code reviews with a testing focus. Why I would recommend it? Because it's a low cost, but it brings a lot of value. This way, the team starts considering quality upfront without needing extra tools. Developers could look for gaps, edge cases, and potential issues as part of their review process.
Yes, code reviews are such a practical way to catch issues early without needing any extra tools or automation. It helps with collaboration, it helps with sharing knowledge, and it's just a great tool that all it takes is really, sitting two people either side by side or on a Slack huddle. It doesn't take a lot at all. It's more of a mindset shift than anything else. So remember, it's not a all or nothing thing. And even if not every engineer is doing code reviews, getting a few people, getting the process set up is an easy and quick way to get started.
Yes. And once a team is comfortable with testing focused code reviews, you can start adding basic unit tests alongside code changes. Developers can introduce these tests for functions or modules they're already working on, especially in critical areas. And this makes testing a gradual, manageable part of the workflow.
Absolutely. If you keep it incremental, focusing on a few happy paths and basic error scenarios, you will build up coverage over time without overwhelming anyone. This approach gives you a gradual build up in quality without heavy resourcing. So start with testing focused code reviews and then add on top of those unit tests that would be covering the current changes that are being made to the code. Small steps, big impact.
Yes, baby steps, everyone, baby steps. All right, so now it's time for our tip of the day segment. Today's topic is contract testing. We talked a little bit about it earlier today, but we're going to dive a little bit deeper here. So contract testing is a powerful strategy to verify that different services or components in a system interact precisely as expected. So there is two main types of architecture that we usually encounter these days in software. It's a monolithic architecture or a microservices architecture. So contract testing is particularly beneficial in microservices architectures, where each service has a defined contract or agreement governing how it interacts with other services.
That's correct. And unlike testing an entire system, contract testing focuses on the communication between individual services. So picture this, right? You have service A, and it depends on service B to provide specific data. With contract testing, we can confirm that service B consistently meets the expectations set by service A, even as service B evolves or undergoes independent changes.
Yes, that's exactly what it is about. The contract, right? The agreement. Literally an agreement. And if we talk about like some tools that can help us starting with contract testing, then one of the leading frameworks that's used for contract testing is PACT. PACT enables team to define expected interaction between services in the form of contracts and checks that those contracts remain valid over time. This approach allows team to catch integration issues early, preventing discrepancies before they impact end-to-end testing. Contract testing supports shifting testing left by making quality validation faster and more resilient.
That's it. Thank you, everyone. And that's a wrap on today's episode of Engineering Quality. We've covered a ton of stuff here today. We covered shift left testing, the automation pyramid, practical strategies like contract testing to level up your testing practices.
Yeah, exactly. And we hope you found this episode insightful and that we've given you enough practical insights that you can apply to your projects. Embracing these practices benefits the whole team, right? So we hope that there's at least one thing that you can take away from today's episode and implement or use to improve your processes on your team.
Yes, big or small, we hope it has been helpful for you. And do not forget to subscribe to our podcast for more insights and discussions on software testing and engineering. Follow us on Instagram at engineeringquality_podcast and on X, formerly known as Twitter, at engineeringqual. It's engineering QUAL.
Thanks for tuning in, everyone, and we hope to see you in the next episode. Happy testing.
Bye, everyone. Thanks for listening.
Bye.